Linear relation and rate of change. In these set of examples, we are trying to understand how to write a real life situation or how to represent a real life situation in the form of algebraic equation. Now in all these situations, we have constant rate of change and therefore we can represent them as a linear relation. A linear relation in the form of y equals to mx plus b, where m, which is the slope of a line, represents the rate of change, and b, which is y-intercept, represents the initial value or initial amount. So b is equals to y when x equals to 0, and that is what we mean by saying initial value or initial amount just at the starting when x is 0, y is equal to b. So that is the y-intercept and also the initial amount. And now when you solve these questions, with every example, x and y will have different meaning. But the base remains same, that is x is the independent variable and y is the dependent variable. Y is dependent on x. So let's read the question slowly and try to understand how to write the equation. Question 3. Temperature of water is increasing from room temperature of 25 degrees centigrade at the rate of 4 degrees centigrade per minute. Now, read it once again. It says temperature of water is increasing from, that means initial temperature, right? Room temperature of 25 degrees centigrade. That means this is the initial temperature, right? Let me write it in a different ink, okay? So that becomes the value of B, right? Which is initial temperature. Correct? And it is increasing at the rate of, so it is already written, rate of 4 degrees centigrade per minute, right? So that becomes slope m. So rate of change, which is same as slope m, is 4 for us. Do you get it? Now the other thing is, what is dependent on what and what is independent? So this unit, degrees centigrade per minute, gives you a clue. Degree centigrade is temperature, which is dependent on time in minutes. Correct? So here, y is temperature, right? Is temperature in degree centigrade. And x is time. Time in minutes. So that is how we need to define all our variables. Now once we define all our variables, we can write down a linear relation to represent this situation. So we can write y equals to rate of change is 4 x plus initial amount of 25. I hope you understand, right? Y equals to 4x plus 25. Every minute temperature is rising by 4 degrees Celsius. Do you understand? So if you have started heating the water now, it is x equals to 0, 25 degrees. Next minute it will be 25 plus 4, and the next minute 25 plus 4 plus 4. So every minute it goes up by 4 degrees Celsius. So that is how we understand this and represent the situation. Now let's move on to question 4. It says rent of the car is based on fixed daily charges of $40 and a cost of $0.25 per kilometer. Now again, fixed daily charges of 40 is what? Is the value of B, correct? That's the initial cost. Whether you drive or not, you have to pay $40. and that is what we call initial value when x is 0. X is your independent variable, correct? Which is distance in this case, in kilometers per kilometer. So whether you drive or not, you have to pay $40 if you have rented a car. Now rate of change, or M, let me say rate of change, or M, is 25 cents per kilometer or $0.25 per kilometer, correct? Now here, what is your independent variable? X. X is distance in kilometer, correct? So X is distance in kilometer. And what is Y? Y is cost in dollars. So Y is cost in dollars. The total cost, you can say, in dollars, correct? So that is how we can define our variables. And now once we understand this, we can write our equation. Y equals to rate of change 0.25 x plus fixed cost of $40. So that is how we can represent this situation in a form of algebraic equation. Since the rate of change is constant, remember, all throughout, 25 cents per kilometer, constantly charged, whether you go 10 kilometers, 100 kilometers or 1000 kilometers. We can represent this as a linear equation. However, if you have a situation where rate of change is not constant, you cannot write a linear relation. Then the relation may be different but not linear, okay? So remember that part, okay? I hope you appreciate and understand it. Move on and quickly answer most of the questions following. Thank you and all the best.